Finally, we get into the percent problems that are much more based in reality than the things that we've been seeing so far. But the things that we've been seeing so far, we're going to bring into play in order to work through these kinds of problems. The percent problems that we've got going on fall into two categories, either the percent increase or the percent decrease kind of problem. With the percent increase, there is some sort of original amount that is going to be increased by some percent. So for instance, in terms of money, if we have as 100%, we've got 4 bills. Doesn't matter what kind of bills they are. Dollar bills, $5 bills, $10 bills, Benjamins, doesn't matter. If we're going to do a 25% increase, we're going to start out with that 100%. Increase means we're going to add. 25% means whatever bill we've got, we're going to add one more extra to it. Flip side, decrease would mean that we're going to start with that original amount and then subtract. And so what we've got are these key words and phrases that are going to lead us to, are we talking about, at the most basic level, an increase situation or a decrease situation? So we want to look for the keywords and phrases that are going to point us in the proper direction. Increase situations, tax, like income tax, sales tax, interest that you might have either applied to a bank account or a credit card account or your retirement account. Appreciation, referring to something that goes up in value, like a classic car maybe. And tip, as in tip your server. When you go out to eat, it is customary to now tip 20% if it's good service, 25%. If it's bad service, you still give the person a tip, usually 15%. Decrease situations, sale or discount, kind of interchangeable. So if you go out and you buy a pair of shoes that are on sale, or you have a discount store. Loss, if something is affected so that the value is decreased because of a loss. Or damage. Depreciation, something also going down in value. Usually that sort of thing is, for instance, you buy a brand new car and, as they say dramatically, as soon as you drive it off the lot, it's not worth anywhere of what you just paid. Keywords and phrases, we're on the lookout for those so that we know which way to go. Increase or decrease. Are we doing a little adding? Are we doing a little subtracting in terms of putting our information together? Don't forget that a lot of the things that are showing up here are tied to things that you have practical, realistic experience with. So use that experience. Maybe, for instance, you say to yourself, let's make the situation a whole lot nicer. Let's literally talk about not 100%, but $100. What do I do to figure out the tax? What do I do to figure out the tip? What do I do to figure out the sale or the discount? And you give yourself a way of being able to put those pieces together, and then, rather than the nice $100 that you were using, you can use whatever numbers are actually provided in the problem. So don't forget to use your experience, your real life experience over the years, to help you work through these kinds of problems. Because both of these situations work out very similar to one another, what we're going to do is look at only a single example and try to piece things together from start to finish in order to figure out, in this case, what was the original cost of a car. When we start at the actual beginning of the problem and read through, we're looking for one of those keywords and phrases still at the top of the screen to tell us if we're dealing with a percent increase or a percent decrease. So a car generally depreciates 30% of its original value in the first year. Do we have one of our keywords and phrases mentioned? Tax? No. Interest? No. Appreciation? No. Tip? No. Sale? No. Discount? No. Loss? No. Depreciation? Close. We have depreciates. Well, there we go. That means that we are looking at that keyword connecting to a percent decrease Specifically, they tell us a 30% decrease. Now, before we start getting further into what might be happening with any of the other pieces of information in this problem, what we want to remember is that this is one possible connection to the information that is in the rest of the problem. So the percent that's mentioned might be directly tied to an amount of money that is mentioned later on. But there's another possibility, and that would be not the 30% that we're going down, but what happens after the 30% takes place. The 30% decrease takes place. So, to put it more directly, not the decrease, but what's left over. So let's just make a quick note of that, just in case we need to worry about that aspect. What's left over? Well, we said a few minutes ago that we always begin with the idea of 100% as our starting place, and that because we're talking about a decrease, we would be subtracting specifically 30%. Then what we're looking at would be 70%. Now, again, we said what's left over. To be a little bit more clear as it relates to the problem, there's a reference to the original value. So what's left over out of the original value? 70% of the original value. And the word cost is also mentioned in the problem as well, so it doesn't matter which of those two words you might prefer, but what's left over? 70%. Decrease 30%, but what's left over is 70%. We're going to make a connection to one of those 2%. So now we need to take a look at the rest of the information. So the second sentence, to read that carefully and think about what that is telling us. A car is worth $27,300 after the first year. They've given us a dollar amount. Is that connected to the amount of money that we have decreased? Or is that connected to the amount of money that's left over, the amount of the value that's left over that remains? A car is worth $27,300. That's a value after the first year. Okay, so original value, day 0. After the first year, so day 366. Value, $27,300. That money amount does not connect with the 30% decrease. That money amount connects with the 70% of the original value. So what we can do is create this very simple statement that says the $27,300 is 70% of the original cost. And we can now choose to work that through. Now that we've got a distilled version of what's going on in this problem, we can work through this based on our two choices, either the decimal way of doing things or the ratio way of doing things. So if you work through things, for instance, in the decimal way, we're translating 27,300 equals 0.7, and we don't need an extra 0 in there. We'll use the letter C for cost. We would need to now divide on both sides to get the, let's remove that comma, just to avoid possible confusion. We would need to divide on both sides by the 0.7 so that we could get the C by itself. And that would give us a division problem to work out. 27,300 divided by 0.7. If we go ahead and work that out, we would get a cost of 39,000, which seems realistic, seems like that would be in the right ballpark. Now again, if you are one of the folks that prefers working through things in the ratio fashion, the ratio that you would be setting up begins with the percent. 70% as a ratio means 70 over 100. And the other ratio that we need is goes on top. The is stuff refers to the 27,300. The of stuff goes on the bottom, so cost stuff going on the bottom. A little cross multiplying gives us 70C equals 27300 times by 100 means I can just slap on 2 extra zeros. I would need to divide by 70 on both sides in order to get the C by itself. And by working through that division process, again, I'm going to get that same answer of 39,000, which is in the right ballpark. If you take a moment and think about things, does that seem reasonable? 30%, roughly a third. Roughly a third is about 13 grand. 13 grand minus from the 39 grand gets me 26 grand. 26 grand's pretty close, at least ballpark, pretty close to the 27,300. So, roughly speaking, I seem to be in pretty good neighborhood here. Most importantly, I don't have an answer that's unrealistically small. Like for instance, 3,900 wouldn't fit. My original cost, my original value has to be higher than the 27,300 that they gave me. 3,900 as an answer would not work. If instead I had messed up my decimal point in a different way and gotten an answer like 390,000. Well, remember that after only 1 year, 30% of the value is gone, and the value at the 1 year mark, 27,300. 390,000 dropping all the way down to 27,300 is way too big of a drop to match up with this 30% decrease. So I can get at least in the right ballpark if I'm thinking about my answer and saying, does it seem to match the facts that are presented in the problem? So always a good idea when you're working through problems, whether they're ratio problems or percent problems, anything at all that's a word problem, ask yourself, does my answer at least seem to be in the right ballpark? And this one does. So specifically, to have our final answer very clearly presented, we would say that the original cost is $39,000.